Here's something I assumed for years without checking, that this was a reasonable plan. A volcano is already on fire. Trash burns. These two facts seem like they should connect into a sentence that ends with problem solved. I was wrong. Not a little wrong. Wrong in a way that takes some effort to fully appreciate. Let's work out why. The first number we need is 2.12 billion. That's how many tons of solid waste the world produces every single year. Write that out. 2,120,000,000 tons. For comparison, the Great Pyramid of Giza weighs about 6 million tons. So we're producing annually roughly 350 Great Pyramids of garbage. We need somewhere to put them. Volcanoes seem large. Let's find out if they're large enough. There are about 1,500 volcanoes on Earth that are considered active, meaning they've erupted in the last 10,000 years. Only around 50 actually erupt in any given year. Most of the 1,500 are just sitting there, which is good for us because we need a place to throw things. But here's where the geometry becomes uncomfortable. A volcanic crater, even a big one, is usually between 200 meters and 600 meters across. Kilauea's main crater, one of the most active volcanoes on the planet in Hawaii, is about 1.2 kilometers across. That sounds large. A standard municipal landfill is often 3 to 5 kilometers across. The volcano is smaller than the landfill we already have. So we're not replacing a landfill with a volcano. We're replacing a large flat space with a much smaller hole, which also happens to explode. Let's say we decide to go ahead anyway. Pick a volcano. Let's go with Kilauea, since it's cooperative and well studied. You fly in 2.12 billion tons of rubbish. Where exactly does it go? The lava lake inside Kilauea sits at roughly 1,000 degrees Celsius. Plastic melts at somewhere between 120 and 180 degrees, depending on type, so the plastic is fine. It vaporizes immediately. The problem is what it vaporizes into. Burning plastic at high temperatures releases hydrogen chloride, dioxins, and furans. These are not obscure concerns. The Stockholm Convention, a UN treaty that came into force in 2004, specifically lists dioxins and furans as persistent organic pollutants, chemicals so stable and toxic that the international community decided, collectively, that producing them needed to be restricted by treaty. We would be producing them by the billion ton, with a chimney the size of a large building and no filter. Your kitchen trash alone, the bag you pulled out this morning, contains enough PVC, from packaging, plastic wrap, synthetic fibers, that burning it without proper scrubbers generates chlorine gas. At industrial scale, in an open volcanic vent with prevailing winds, we've just built the largest unregulated incinerator in human history. It has no stack height limit. It has no emissions permit. It is technically in violation of the Clean Air Act in every country that has one, simultaneously. Dang. Let's set the air quality problem aside for a moment, not because it's resolved, but because something structurally more interesting is about to happen underground. Volcanoes aren't just holes, they're pressure systems. Magma beneath a volcanic vent is under enormous pressure at Kilauea. The magma column is sustained by pressure from the mantle. You add mass to the top of that column and you change the pressure balance. Volcanologists have a term for what happens when foreign material falls into a lava lake. They call it laze, lava haze, the plume of hydrochloric acid and steam that erupts when any water-bearing material hits molten rock. A single garbage bag, maybe 15 kilograms, wet from last Tuesday's leftovers, hits a lava lake and produces an immediate steam explosion. We are proposing to drop 2.12 billion tons of garbage bags, many of them wet, all at once, repeatedly, into active volcanic systems. The steam explosion problem is not theoretical. In 2018, a lava flow from Kilauea entered the ocean and produced laze columns 100 meters tall from contact with seawater. That was a lava flow meeting the ocean, a slow distributed process. We're proposing to drop compressed municipal solid waste into the vent at volume. The resulting steam events wouldn't be columns, they'd be lateral blasts. The USGS, the United States Geological Survey, the people who actually measure these things, classifies lateral blasts as one of the primary kill mechanisms of volcanic events. Mount St. Helens in 1980 produced a lateral blast that flattened 600 square kilometers of forest in under 3 minutes. We would be engineering the conditions for this deliberately. The plains are fine. Everything near the volcano is less fine. Now, there's an angle here that most people miss completely, and it reframes the whole problem. We don't actually need to drop the trash into a volcano to incinerate it. We already have a technology that burns waste at 850 to 1200 degrees Celsius, hotter than most lava, filters the exhaust, captures the heat, and converts it to electricity. They're called waste-to-energy plants, and the EU operates over 500 of them. The largest, in Shenzhen, processes 5,000 tons of waste per day. These exist. They're running right now. The reason we don't use them everywhere isn't technology. It's that building, one costs around $500 million and takes a decade to permit. A volcano, by contrast, costs nothing to build and is very difficult to permit for a different reason entirely. So the situation we're in is we have the technology to do what we're imagining volcanoes do, more safely, without the lateral blast, and we're mostly not using it. That's a slightly embarrassing position for the species, but let's follow the volcano plan to its logical end, because there's one more thing that needs to be said. The volume doesn't work. Let's do this precisely. Kilauea's lava lake has a surface area of roughly 0.4 square kilometers. To absorb 2.12 billion tons of waste, even if we assume it all burns completely, which it won't, we need the volcano to erupt at a rate that clears its own crater continuously. Kilauea produces roughly 0.5 cubic kilometers of lava per year. 1 cubic kilometer of lava weighs about 2.8 billion tons, so the volcano's total annual output, in weight, is just barely enough to match global waste production. We would need every volcanic eruption on Earth, every cubic meter of magma, every tectonic exhale the planet makes in a year, dedicated entirely to garbage disposal. No eruptions for anything else. Lava flows scheduled around refuse collection. Let's talk about who survives this plan entirely unaffected. Ants, specifically leafy cutter ants. They produce no plastic, no municipal solid waste, and maintain a composting system inside their colonies that has been running continuously for 50 million years. Their waste management is closed loop. Ours requires us to consider weaponizing a tectonic event. This contrast does not reflect especially well on us. Here's the thing that I think most people don't carry with them when they imagine the volcano plan. The trash doesn't disappear, even if we burn it perfectly. 100% combustion, no residue, no solid byproduct. We've just converted solid waste into gaseous waste. The carbon in every piece of rubbish becomes carbon dioxide. The sulfur becomes sulfur dioxide. The nitrogen becomes nitrogen oxides. The 2.12 billion tons don't vanish. They relocate from the ground, where we could in theory contain and manage them, into the atmosphere where we cannot. We've solved the landfill problem by creating a climate problem of equivalent mass. Conservation of matter is undefeated. The aluminum, by the way. Aluminum doesn't burn. It melts at 660 degrees and sits there, pooled in the lava, forming an alloy with the basalt. Aluminum basalt alloys are brittle and structurally useless. We'd be converting recyclable aluminum, a material that can be recycled indefinitely using 5% of the energy required to produce it from raw ore, into a non-recyclable alloy sitting inside a volcano. That's not a net gain. The aluminum stays in the lava. That's probably not ideal. I've been assuming throughout this that we're talking about a dormant-ish volcano that we visit to dump things. The more I look at it, the more I think the actual proposal floating around the internet is even more direct. Drop it into an actively erupting vent, let the lava deal with it. Which brings us to the logistics of approaching an erupting volcano with a garbage truck. The temperature at the edge of an active lava flow is around 600 degrees Celsius, even 10 meters from the flow. Truck tires fail at around 300 degrees. We need, at minimum, a different kind of truck. Then a different kind of road. Then a different kind of driver. Then, presumably, a treaty revision. The 1963 treaty establishing the Smithsonian Institution's Global Volcanism program doesn't specifically prohibit using active vents as landfill, but the Outer Space Treaty somehow does address waste. Article 9 requires that parties avoid harmful contamination of celestial bodies. If we're looking for legal precedent for don't put your garbage in natural geological formations, we have to go to space law. That's the nearest applicable framework. We've been talking this whole time about a plan that feels like it should work. It has the basic shape of a solution. Large thing is hot, other thing needs to go somewhere. Combine. The satisfying click of that logic is exactly why it keeps coming up. But the geometry doesn't work. The chemistry makes it worse. The pressure physics are dangerous. And even if all of that were solved, the mass doesn't disappear. We've just moved it. Sometimes the reason we invented landfills is that landfills, for all their problems, don't explode sideways. If that made you think of something you've been sitting on, drop your own question below. The stranger, the better.